Well, good morning, everyone, in Honors Algebra 2. It is Monday, April 20th, and we are continuing on in our Trigonometric Graphs and Identities, Chapter 13, with 13.7 Trigonometric Addition Formulas. Okay, so if you wanted to find the sine of 75 degrees, I'm just looking here at the little top example they have in the book here. You could put that in your calculator and you could get a decimal approximation for that. But sometimes you want to know the exact answer. Well, we've heard exact answer before. Whenever we see exact answer, we think of similar triangles. So that's what actually we're going to be using today in addition to these special formulas. Now, down here in the gray, we have the addition formulas for the sine and cosine. These are 4 special formulas that you will be using in this section. You'll also be using them again when you get to honors pre-calculus as a junior. But for this year, you obviously don't have to memorize them because everything is open book. When you become a junior, unless we have another COVID outbreak, you will need to know these formulas. So for this year, you just have to be able to apply them. So let's look at the first one. What is the sine of 2 different angles, alpha plus beta? Well, we just use a special formula. You take the sine of the first angle, multiply it by the cosine of the second angle, and add to that the cosine of the first angle, multiplied by the sine of the second angle. Now, the difference, the sine of the difference of 2 angles looks a little bit different. The only thing different here is we are subtracting. Now, when we get to the cosine of the sum of 2 angles, we have cosine alpha, cosine beta, minus sine alpha, sine beta. It looks a little different. Then, when we want to do the cosine of an angle minus a different angle, we do the cosine alpha, cosine beta plus. And so the signs are different there. Okay, so you do not have to memorize these, but let's look how these work in some examples. Now, before we do that, let's look at this caution right here. And the caution says, let me go red for caution, the sine of the sum of 2 angles is not the same thing as the sine of the first angle plus the sine of the second angle. So just be really careful about that. Be really careful about that. That is not true. Okay, now let's move on to our lecture for today. And it's really not going to take up a lot of time, but we're going to find, here we go, let me get my little pen here, I'm going to go red. We want to find all right, come on to me, the exact value of each of the following. So that means we are going to be using our special triangles, okay? Now the sine of 75, let me just start by saying this. There is more than one way to do this, but what I'm going to do is I'm going to think about, I've got my 30, 60, 90. Here's my 30, 60, 90. And then I've got my 45, 45, 90 triangles. And remember, this is 1, 1, root 2. And across from the 30, I have a 1. Across from the 60 is root 3. And the hypotenuse is 2. So I'm really looking, when I look at the sine of 75 degrees, I want to think in terms of multiples of 30 degrees and 45 degrees, okay? I would list 60 also, but 60 is a multiple of 30. So let's think about the sine of 75. Well, the sine of 75 can be rewritten as the sine of 45 degrees plus 30 degrees. I'm going to put that in parentheses, okay? So that is the sine of my alpha angle plus my beta angle. Now, I'm not going to rewrite the formula for you because you can be looking at it as I write along here. But we know that we're going to use it's the first formula of those 4 in the gray box. I'm going to take the sine of alpha, which is 45 degrees, and multiply it by the cosine of beta, which is 30 degrees. Then I'm going to add to that, what does my formula say to do? Take the cosine now of 45 degrees and multiply it by the sine of 30 degrees. So let's look up at our special triangles here, and let's first look, what is the sine of 45 degrees? Well, let me go ahead, let me go blue here. The sine of this blue angle, 45 degrees, is going to be the opposite over the hypotenuse, 1 over root 2. Well, 1 over root 2 can be rationalized to root 2 over 2. Okay. Now I'm going to multiply that by the cosine of 30 degrees. So let's go ahead and look up here. I'm going to go green. The cosine of 30 degrees is going to be my adjacent over my hypotenuse. So that's going to be the root of 3 over 2. Oh, I left it green. How fun is that? Okay. Now we'll just leave that green. Plus, now the cosine of 45 degrees is going to be the same thing as the sine of 45. It's going to be 1 over root 2, which is root 2 over 2 when you rationalize your denominator. And now we want to do the sine of 30 degrees. So I'm going to go yellow here. The sine of 30 degrees is going to be my opposite over my hypotenuse, which is 1/2. I'm going to go back to black. I'll leave the other one on the screen. Okay, now we need to simplify this. And so we're getting the root 6 over 4 plus 2 root 2 over 4. So that is going to just simplify. You make it one fraction over 4, root 6 plus 2 root 2 over 4. And that is the exact value of the sine of 75 degrees. Now, let's look at the cosine of 195 degrees. Well, there are several ways to do this, okay? There's several combinations. We could use the sum of 135 and 60. There's several we could use, but what I'm gonna do is I'm gonna go ahead and use a subtraction formula just so we can, excuse me, go ahead and practice that. So I'm going to make 195 the cosine of 240 degrees minus 45 degrees. Okay, now you say, how did I come up with that? Well, remember at the top up here, let's look up here, I wanted to have multiples of 30 and 45. And 240 is a multiple of 30, and of course 45 degrees was used. So let's go ahead, we're going to do the very last formula now. We're going to do the cosine of alpha minus beta. So we're going to do the cosine of, we're going to start with the cosine of alpha, which is 240. We'll figure that out in a minute. Okay, times, follow your formula, the cosine of 45 degrees. And then I'm going to add to that the sine of 240 degrees times the sine of 45 degrees. Okay, now I'm going to go ahead and look, I'm going to go ahead and draw where 240 degrees would be. So 240 degrees is in the third quadrant. It's 180 plus 60, isn't it? So I'm going to create, so here it is. That is 240 degrees. But what I'm going to do is I'm going to make a reference angle here. So 240 degrees, this reference angle is 60 degrees. It's 180 plus 60 is 240. Now, let's go ahead and figure out what the cosine of 240 is. Well, across from 60 is root 3. The hypotenuse is going to be 2, and across from the 30 is 1, okay? So remember, this is my right angle, and the 30 would be down here. Okay, so I have my special triangle, but we have to be careful. In the third quadrant, your x and your y are negative. Your x and your y are negative. So the cosine of 240 is going to be my x over my r, or my adjacent over my hypotenuse, which is negative 1/2. Now let's go back. The cosine of 45 degrees, we knew that from the previous problem. That's root 2 over 2. Now let's add to that the sine. Why am I putting that there? The sine of 240. Well, the sine of 240 degrees is going to be my y over my r, and my y is negative root 3 over 2. So I'm going to put a negative here. Root 3 over 2. I'll go ahead and keep parentheses there. And then the sine of 45 degrees is the same as the cosine of 45 degrees. Okay, so now let's go ahead and multiply what we have here. We have, let's see, negative root 2 over 4 minus root 6 over 4. So I'm going to go ahead and combine those. Now, there's more than one way to do this. I'll tell you what the book does. The book does, I'll tell you what I think is the simplest. That you can do negative root 2 minus root 6 all over 4. That is fine. If you want to put the negative sign to the left of the fraction bar, you can do that, but be careful. It's going to be the negative of root 2 plus root 6 over 4. So you have to be real careful. That negative sign is distributed to both of the binomials in the numerator. So either one of these is correct. I would just be on the safe side and go ahead and use this first one. But either one is correct, but I'll be looking for that. All right, let's go to the next page. Now, on the next page here, on the next slide, I'm going to prove an identity. Now, these aren't going to be as hard as you think, because what I have here is the cosine of the difference of two angles. And one of my angles is just theta. It's just theta. Okay, so we want to prove the identity, which is an equation where both sides are true. So let's take the more complex side, the left side, and set it equal to negative sine theta. So let's go ahead. And we know from our difference of cosine of difference of two angles, that's the fourth formula, that the cosine, and this can be your alpha minus beta, okay? We're going to take the cosine first of the alpha angle, 3 pi over 2, and multiply it by the cosine of the beta angle, which is theta. And we add to that the sine of the alpha angle, 3 pi over 2, times the sine of the beta angle, which happens to be theta. Okay, now, cosine of 3 pi over 2. Well, 3 pi over 2, in case you're not sure, let's convert that to degrees so we know what we're dealing with. So pi radians is 180 degrees down here, and pi cancels out. And 180 over 2 is 90, and 90 times 3 is 270 degrees. So we're dealing with a quadrantal angle. We're dealing with 270 degrees here. Okay, so there's my angle. Now down here, remember, we make our R value equal to 1 to make it easy. And this point down here is 0, negative 1. So my X value is 0, my Y value is negative 1, and my R value is positive 1. R is always positive. So let's find the cosine of 3 pi over 2. Well, the cosine of any angle, I'm just going to call it X. Cosine is your X over your R. So in this case, it's going to be, what is my X value? 0 over 1. And so the cosine here is 3 pi over 2, or 270 degrees, is 0. And I'm multiplying that by the cosine of theta. Now, I'm going to add to that the sine of 3 pi over 2, and the sine of any angle is y over r. In this case, it's going to be negative 1 over 1, which is negative 1 times the sine of theta. Well, what do I get here? This cancels out, and I get negative sine theta. And it's really as simple as that. So you've got some written practice problems to do, and then I've given you some mixed review. So we're going to be spending, I think, 3 days talking about some of these different trig formulas now that you just have to, kind of crunch it out. And always draw those angles in the quadrants so you know where X is positive and where X is negative. So just be careful with that. And remember to look for multiples of 30 and 45 when you're finding the exact value of these angle measurements, of sine and cosine of other angle measurements. Okay, well, have a great day, and I will see you at Zoom if you need me at 10 for anything, and I hope you have a blessed Monday. I'll see you at Zoom or on Tuesday. Bye-bye.